Okay, so for today's notes, we're taking what we did yesterday with law of sines and cosines and applying that to some word problems. So looking at question number 1, you have a ski lift that begins at ground level 3/4 of a mile from the base of the mountain, whose face has an angle of elevation of 50 degrees. The ski lift ascends in a straight line at an angle of 20 degrees. Find the length of the ski lift from the beginning of the trip to the top of the mountain to the nearest 100th of a mile. All right, so from the problem, we know that the ski lift is 3/4 of a mile from the base of the mountain. 3/4 would be the same as 0.75 miles. All right, so now the 50-degree angle of elevation is coming from the base of the mountain. So if you imagine that this is our mountain, then at the base of the mountain, that angle is 50 degrees. So from the base looking up, if we were to extend this side, this angle would be 50 degrees. All right, the ski lift ascends at an angle of elevation of 20 degrees. And the length that we're looking for is the length of the trip from start to finish. Now, if you think about the angles down here at the bottom, 50 degrees and then the missing angle next to it should make a linear pair. So if we took 180 and subtracted 50, then inside the triangle we would have 130 degrees. And then we could similarly take 180 minus 130 minus 20 and get that this angle at the top should be 30 degrees. Okay? So now we have enough information to make a pair, which would be law of sines, because I can compare x and 130 because they're opposites, and I can compare 30 degrees and 0.75 because they are opposites. So this would be a law of sines set up, and we would compare sine of 30 degrees over 0.75 miles, and then the sine of 130 degrees over x. And just like yesterday, cross multiply. So 0.75 times the sine of 130, and then x times the sine of 30. And what we're going to end up doing is actually dividing both sides by the sine of 30. So now what you could do in your calculator is we could just leave this written as 0.75 times the sine of 130 and then just divide the whole group at once. Or you can write it as a decimal, but make sure that you leave it to at least 3 or 4 decimal places. And I get that x is roughly 1.15 miles. And since it said to the nearest 100th, then we'll leave it to 2 decimal places. All right. Secondly, it says Carmen and Jamal are standing 1 mile apart on a straight road. So we could go ahead and sketch that. You have Carmen, have Jamal. There's a road between them that's 1 mile apart. They observe a hot air balloon between them directly above the road. So somewhere up here, we have a balloon. The angles of elevation from Carmen and Jamal are 60 degrees and 75 degrees respectively. So from Carmen, the angle of elevation to the top would be 60 degrees. And from Jamal, the angle of elevation to the top would be 75 degrees. Draw a diagram to illustrate, which we did, and find the height of the balloon to the nearest foot. So essentially, this is what we're looking for. So now if you think about the triangle overall, it doesn't necessarily tell you that the balloon is halfway. So we can't take this 1 mile and cut it in half to say that this is half a mile and this is half a mile. But what we could do is we could figure out the angle that's left up here at the balloon by taking 180 and subtracting 60 and 75, and we get that the angle missing at the top is 45 degrees. All right, what we could do is if we could take this overall triangle and somehow split it in half, then we could figure out the altitude or the height. But in order to do that, you would need to know one of these two sides. So if we just pick, let's say we want to find the side on the right. We have enough information here to make a pair. 60 and X would go together. 45 and 1 mile would go together. All right, so my first step would be to do law of sines using what I have so far. So we would say sine of 45 over 1 mile, is the same as sine of 60 degrees over X. All right, when we cross multiply, we get sine 60 times 1 equal to X times the sine of 45. And we're going to end up dividing both sides by the sine of 45. All right, so sine 60 divided by sine 45 comes out to be 1.2. We'll leave it to the 10th now. And we're currently measuring in miles. All right, so if we were to kind of re-sketch, this is what we have so far. 75 degrees, 1 mile, 1.2 miles, 45, and 60. But now what I could do is I could even take out the 45 and the 60 and split my triangle down the middle, creating a right triangle on the right. Now again, we don't necessarily know that 1 is split evenly, so we could just disregard. And using only the triangle at the right, if we're looking for how tall, then this is like what we've been doing the past few days. From 75, this would be the opposite and the hypotenuse. So we could say sine of 75 equals X over 1.2. Multiply 1.2 by the sine of 75, and we get that the height of the balloon is 1.16 or 1.2, says to the nearest foot, so that's roughly 1.16 miles. Be remember to convert miles to feet. 1 mile has 5,280 feet. So if we take 1.16 and we multiply it by 5,280, that is roughly 6,125 feet, which seems like a reasonable height for a hot air balloon. Okay. For question number 3. The accompanying diagram shows the plans for a cell phone tower that is to be built. Find the height of the tower to the nearest foot. So this is what we're looking for. So what you kind of need to think about for this problem is really that you could separate these pictures into 2 triangles. If we could use the triangle on the left to find the side that attaches, the side that they share, then when you transition to the second triangle, since it has a 90-degree angle, we can just do regular sine, cosine, tangent. All right, so similarly to the first one, you know that 65 degrees and the angle next to it should make a linear pair. So if we took 180 and subtracted 65, that would give us 115 degrees. And then similarly, we could say 180 minus 115 minus 32, and that would give us that the angle at the top is 33 degrees. All right, from there, we could set up a ratio with opposite sides using law of sines. 100 would be opposite from 33 degrees, and if our goal is to find the side that they share, then I would want to compare 32 with X, or you could call it Y, some other variable to keep us from being confused. So using law of sines, we would say the sine of 33 degrees over 100 feet is the same as the sine of 32 degrees over missing side. All right, cross multiply. So 100 times the sine of 32 equals y times the sine of 33. And then what we're going to end up dividing by is the sine of 33. Now again, you're more than welcome to go ahead and type 100 sine 32 in your calculator and get a decimal. Just leave enough spaces after the decimal to kind of keep our answer more correct. The fewer times we stop and round, the more accurate our solution will be. So side that they share would end up being 97.3 feet. All right. From there, now you can kind of look at the right triangle individually. We're looking for the height of the tower, and this is 97.3. So from our angle of 65 degrees, this would be the opposite. This would be the hypotenuse, so this would be sine. So sine of 65 equals x over 97.3 multiply 97 and sine 65. And we get that the tower is 88.2 feet tall. All right, question number 4. While sailing offshore, Donna sees a lighthouse and calculates that the angle of elevation to the top is 3 degrees. When she sails her boat 700 feet closer, she finds that the angle of elevation is now 5. That should say now. How tall to the nearest tenth of a foot is the lighthouse? So this is one similar to what we had in our homework the other day, where you can tell that there should be 2 separate triangles because originally she's a certain number of miles out or a certain number of feet, but then she moves in closer and sort of creates a second triangle. All right, so if we kind of sketch a picture, Donna's in a boat, and then somewhere across the water she sees a lighthouse. Really amateur sketch of a lighthouse. All right, so we know that the original angle of elevation to the top of the lighthouse is 3 degrees. Then Donna sails her boat 700 feet closer. So we don't know how far out she is originally, but we know that where she starts, she comes inward 700 feet and then she stops with some distance still left over. When she looks up the second time, now that angle of elevation is 5 degrees. Now we would also assume that this angle should be 90 degrees between the lighthouse and whatever ground it's built on, because buildings should be built perpendicular so as not to lean. All right. So we can start this one really the same way that we started number 3. You know that 5 degrees and the angle next to it should make a linear pair. So the first thing I would do would be find my angles. 180 minus 5 would give me 175. And then 180 minus 175 minus 3 would give me 2 degrees at the top. Again, it would be most beneficial to try to find the side that they share. So I'm going to call that side Y. All right, using our law of sines, we could set up a ratio comparing the things that are opposite. So 2 degrees would go with 700 feet. 3 degrees would go with my missing side. So the sine of 2 over 700 feet equal to the sine of 3 over y. When we cross multiply,